Hello, everybody. Welcome to the last Python workshop, Small Problems in Debugging. Well done. We've made it all the way through 6 weeks to the end. So we've looked at all of these other things in the previous 5 weeks, and today we're going to be looking at small problems and debugging. Now, for anyone who doesn't know me already, my name is Claire. I'm one of the TAs at Launch School. You might know me from the community updates, my outrage about scones. So if there's anything that really annoys you, why don't you put it in the chat and just get it off your chest? You know, something today I was being told by Patrick, who said he was tasting tea. I mean, one of them was blue. It can't be tea. Okay, so I'm also a student as well as somebody who writes community updates. And I'm currently in the front end of the core curriculum. I'm currently learning all about the DOM and the document object model. And today we are going to be looking at the PEDAC process. We're then going to solve a problem together, and then we're going to look at debugging. So just a brief overview, the PEDAC process is the primary problem-solving method taught here at Launch School. Then we're going to walk through the process of using that process to solve a coding problem together in real time. So I'm going to need your help in chat to do that. And then after that, we're just going to look at some principles for successful debugging and before hopping back into code editor to work through debugging a program. If you've got any questions as we go along, please put them in the Q&A. I'll try to answer them as we go. I don't want to leave anyone behind. This is a safe space to learn. So questions that you want me to answer, please put in the Q&A. But when I ask you for contributions to help me solve a problem and debug, then I'd like you to put them in the chat, please. There aren't any quizzes this time because it's going to be more interactive anyway. There will be time at the end for further questions as always. And if you need to hop off early, not sure, I haven't done this before. So I'm going to try to keep it to the hour, but just in case, and you need to hop off early, please grab the feedback form. It would be really helpful if you could fill it in and let me know whether this worked, how I could improve it. Okay, so let's have a look at the PEDAC process. Oh, we don't look at the conclusion of the feedback. Right, let's have a look. Here we go. So on the right-hand side, I've got a summary of the PEDAC process. And on the left-hand side, I've got VS Code, which is where I'm going to be coding. So PEDAC is a method to deconstruct a problem rather than just jumping into code without a plan. So first of all, you need to understand the problem, so that involves identifying the problem's inputs and outputs and understanding how to get from the input to the output. There might be information in the problem statement that provides instructions for how to deal with edge cases, like if there's an empty string, return an empty string. If there isn't anything meeting a condition, return -1, those sorts of things. So once we've understood the problem by looking through the problem statement, we then look at examples or test cases that we've been given and make sure that none of those contradict our understanding of the problem. And they may also reveal some edge cases as well as gaps in our understanding. So once we've done that, we should have a good understanding of the problem. And now we're going to identify data structures that we may want to use in our solution. And at this point in the curriculum, it would usually be a list, a dictionary, or a set. And I'd also include in that a string. We don't often think of strings as technical data structures, but in terms of working through a problem, sometimes all you need is strings to keep hold of your information. So I often include strings in my data structure list for this list, as well as a list, a dictionary, and a set. Once we've thought about data structures we might want to use, then we outline our algorithm. This should provide a step-by-step set of instructions for solving the problem, be written in plain English. It's a good idea to aim for something that a person with zero coding knowledge could understand, so that you're really taking yourself away from thinking about code to just thinking of logically solving the problem. So try to make it language agnostic. So it can be coded in any language. And then finally, we code with intent by just translating the algorithm step by step into Python code. Now, at this point, you might be wondering whether it's just quicker to skip all of that and just go straight to coding. And it's a fair question, and sometimes it is. But when problems get trickier, this PEDAC process really, really helps, because it helps solve the two-layer problem, which is when we're learning to code, we're still learning about the syntax of a language and just how to write quite straightforward things. And when we're solving a problem, we're also trying to think about the logic of solving a problem. And when we're trying to do both of those things at the same time, it can make things difficult, just like when you try to write and edit a novel. I haven't, but I can imagine writing and editing a novel at the same time. It's often much better just to get everything down, just write it all down, and then later edit it and finesse it to make it better. And this is a similar sort of thing. If you're trying to figure out the logic of solving a problem while you're also trying to write the code, you tend to be less efficient at both of those things. So PEDAC is a way of just trying to separate those things. So by the time you get to coding, really, you're just translating some very simple steps into code, and it should be quite a straightforward step in PEDAC to do once you are fluent in the language that you are programming in. And when you're not fluent, then it makes it easier, because at that point you can just focus on what is the syntax that I need for this language. I'd also say when I first started using it, it did feel a little bit forced, and it did take me a while to get into it. But now I use it all the time on full convert. I use it just to solve small problems in launch school curriculum. Every year there's an advent of code, nothing to do with launch school, but I do advertise it on launch school. This person runs this advent of code. There's a problem to solve every day of the 24 days leading up to Christmas, and I use PEDAC for that. And then working on small projects, again, I use PEDAC for that as well, because it's a really structured way of working through a problem, and I find it really helpful. And by practicing this process on a simple problem, it means by the time you get to a complex problem, you really understand how to use PEDAC, and so you can concentrate on the difficulty of the problems rather than trying to figure out how to use PEDAC while you're also trying to solve a difficult problem. So I would say try and practice it with easy problems. It will slow you down to begin with, but you'll speed up as you go through, and then later on you will really realize the benefits of this. So we're not just trying to make your life hard. Honestly, it really, really helps solve problems. So let's move on to actually solving a problem. So you can see this on the right-hand side. It's in the Python problems, small problems, easy 3, daily double. So this isn't a problem that I've specifically chosen to demonstrate PEDAC. I've just picked this one, and you'll see how we can break this problem down using the PEDAC process, and hopefully then you'll be a way to go and you can use this on all your own problems. So to practice this new skill, rather than just watch me do it, I'd like you to get involved. And so I'd like to know, this is a safe space to learn, experiment, and make mistakes, okay? There's going to be lots of people, lots of different backgrounds here. So some people might have a lot of experience with coming up with ideas that are beyond you. And there'll be other people that are further behind than you as well, and are very new to either Python or programming or problem solving as well. We'll probably have quite a range of people here. So don't worry about getting involved and just suggesting things, because I'm going to have a look at all the ideas and see which is the most fun. So use Q&A if you've got a question, but I'd like you to use the chat interface to provide suggestions to guide the problem solving process, and that way you can see each other's suggestions. So now I'm going to read out the problem statement. So write a function that takes a string argument and returns a new string that contains the value of the original string with all consecutive duplicate characters collapsed into a single character. And then we've got 6 test cases there. So I'm just going to create a file to work in. So let's call this daily double. And I'm going to open that file up. Move that down there. So I'm just going to copy a template I've got. So I'll just paste this in here. First of all, I've got the problem statement copied out. Then I've got my P, E, D, and A. So we're going to work through each of those steps. And then I've got the examples at the bottom here. So I've left off the C because that is where I'll do it here, the code. So first of all, we're going to deconstruct the problem to identify the inputs and the outputs, as well as any implicit and explicit requirements that are in the description of the problem. So it's important that we get the requirements, obviously, of the problem so we understand what we need to do. And some people find it useful to think about implicit and explicit requirements. So explicit requirements are things that are explicitly stated, and implicit ones are ones that we're figuring out from the information that we've got. And some people separate these out. I don't bother, because a requirement is a requirement and we need to meet it. But it's worth thinking in our head about what, you know, right, we can see the explicit ones. Now let's check to see if there are any implicit ones. And we'll do that as we go through. So let's start with the input. So can you all in the chat tell me what is the input for this function that we're going to write? And I won't move on until somebody's done it. Otherwise, I'm just going to do it on my own. Thank you, Jessie. So the input is a string. Okay. And then what is the output? Thank you, Shelby. What is the output? Also a string. Okay. And while this might feel a bit trivial now, it can be really important when you're doing a problem that's sort of a bit more complicated than this, and we might be going through several different data structures as we go through. It's really important to keep in your head, what is the thing that I'm getting in and what is the thing that I need to get out? And just having it there, I find at the top, just makes me go, make sure that I know I'm getting a string in and I'm putting a string out, and then I just don't get confused. So now we're going to think about what the problem is telling us. So can anyone spot any key terms in the problem that we need to understand? And is it big enough for you to read on the right-hand side? I have to make it bigger with that because it's already the full width. Duplications, okay. Consecutive duplicate, brilliant. We need to find consecutive duplicates. So what does this mean? Can anyone explain to me what they think consecutive duplicate characters means? Yeah, repeating values whenever a character is repeated. If next character equals current character, we might butcher your name here, but Atia? Great. So consecutive duplicate characters. We can think of this the same as being, is the next character the same as the current character? Love that. And that also feels like we might be working towards a way to solve the problem. And that is, I would say, the key term in this problem statement to understand, the consecutive duplicate characters. And then what do we think it means when we say collapsed into a single character? Remove the consecutive duplicates, yeah. Do we remove all of them? Yeah, only one should remain. So return the first value of the repeated character, any duplicates, and it's just now one. Yeah, so collapse into a single character. So we want to keep just one of consecutive duplicate characters. Okay. Now, I do want to mention this now. So PEDAC is something that we use in our 119 interview when we ask students to solve 2 problems in an hour, challenging but achievable by the time you get to that point. And you might not write down as much detail as I'm doing here. So don't take what I'm producing here as some kind of, I need to do this with everyone, because I'm just taking you through it in small steps, because I'm expecting people to be at the beginning of their journey in this. But you write down notes for yourself, so as much information as you need. So if there is a term in there that is new to you and you need to understand it, then you might want to make a note of it. But don't feel like you need to make a note of things that actually you understand. These are your notes to make sure that you understand what you're doing. Okay, so we're now going to rephrase the problem statement in our own words. We could just copy the problem statement, but the purpose of this step is to make sure that we've read and internalized all the information that's available to it. And by rephrasing the problem, we just force ourselves to do it. Because we can say, yeah, I understand, just move on. But by rephrasing the problem, we really force ourselves to think about how we could rephrase it in different words but mean the same thing, and that makes sure that we really are understanding the problem. So if you could have a go in the chat of just a sentence or 2 of restating the problem, please. Thank you, Tom. So find consecutive duplicate values and remove all but one of them. Return the remaining values as a string. I like that. Can I copy it? It's okay. Oh, maybe I can't copy it. Try again. Select all. Oh no, I can't. I'm just going to type it out. So find consecutive duplicate values and remove all but one of them. Return the remaining values as a string. Great. I think that's got everything that we've uncovered. It's got consecutive duplicate values. We're going to remove all but one of them, and then we're going to return the remaining values as a string. Perfect. So now we're going to move on to the examples to see if we can spot any implicit requirements. So we often, the problem statement will give you like the explicit requirements. Sometimes there'll be an implicit one in there. I can't see one this time. And then we might get some implicit requirements from the test cases. And also we should have a look at the test cases to just check that they do meet with our understanding of the problem as it is right now. So looking at the test cases, can anyone provide me with some rules that we need to bear in mind when we're solving this problem? Or anything that we don't need to worry about, because we're looking at the test cases. We've only got to solve the test cases we can see in this case. So is there anything we can see that goes, oh yeah, we don't need to worry about something? So I'm going to answer Janice's question. Just curious why values, not characters. just a way of rephrasing it without just writing exactly the same thing again. I guess it would be fine to say find consecutive duplicate characters too, but values we can use as another way to say characters. Right, so Tom's come up with non-consecutive duplicates must not be removed. Yeah. So do not remove non-consecutive repeated characters. So we can see that in the second test case where we've got A, B, C, A, B, C, C, B, A. So A is repeated in there 3 times, but they're not consecutive. So A is still repeated in the output 3 times as well. So that's a great point. We're only removing consecutive duplicate characters or values. Any other rules that anyone can spot? Don't need to consider the type of character each one is. Yeah. So the same rules apply regardless of type of character, e.g. digits and letters, because that's all we've got here. Anything else? Thank you, Jules. My daughter is called Jules. Okay, maybe we're drying up here. So the things I'm going to say, I'm not going to write all of these out because I think we've got enough information here, but we can see from these test cases that the input string can include numbers, letters, and spaces. All letters are lowercase, so we can ignore any issues with case sensitivity for this problem because we don't have any uppercase letters, so we don't know whether or not they'd be considered to be duplicate or not. We don't need to worry because we don't have any uppercase ones. Numbers are treated the same as letters and they need to be collapsed. Only one test case has a space and it's just one space, so I can just either retain spaces or collapse consecutive spaces into one. It wouldn't matter. It would pass for this. So I think I'll probably just think about spaces as being a character. If the input string contains just one character duplicated, like the third one, then we just return that character. But that's kind of contained within what we've said anyway, because consecutive repeated characters are just going to be replaced by one of that character. And so if the string is entirely that, then we'll just get that back. If the input string contains no consecutive duplicated characters, like the fourth one, ABC, then we just return the string that we get. Again, that's kind of contained within what we've said. And then the last one, maybe that's an edge case. I think I'll write this down. An empty string just returns an empty string. So if the input is an empty string, return an empty string. So we think of that as an edge case. And sometimes you want to deal with edge cases using a guard clause right at the top, so you don't have to worry. You tend to use the guard clauses to make sure that the data that you're getting in is something that you can manipulate. And if I'm worried, if I want to iterate over my string or something, and I'm worried about iterating over something that's empty, an empty string, I might just get rid of that right at the beginning of my code, get rid of it right at the beginning of my algorithm. So understanding the problem and examining the test cases are actually the two most important steps here, because if you don't understand the problem correctly, then you can write an amazing algorithm, beautiful, elegant code, but it's no good because it's not solving the right problem. But having said that, there are diminishing returns as we keep looking at this. So Once you dry up, move on, but don't be reticent about going back and having a look at the test cases, having a look at the problem description if you're getting stuck at any of the other stages, just to check you've not forgotten something or made an assumption. It's always worth getting a little bit, oh, what's going on there? Go back and have a look. So someone's asked me, can I explain the difference between an implicit and an explicit rule? Yeah, so you don't need to know the difference between this because rules are just rules, but some people find it helpful. So explicit rules, so write a function, that's an explicit rule. We've got to write a function that takes a string argument. It says there again, takes a string argument and returns a string. So again, these are explicit rules because they're stated there. Whereas the rule we've come up with, if the input is an empty string, then we need to return an empty string, is an implicit rule because we've just got that from the test cases and it wasn't explicitly stated in the problem statement. The more problems you solve and the more complex they get, the more you might notice these implicit and explicit rules. But like I say, it doesn't matter. A rule is a rule and we need to meet it. So if you're not sure whether a rule is implicit or explicit, it doesn't matter. Just put it down. Okay, so now we're going to have a look at data structures. So the more complex the problem, the more time you spend on this step. But even with straightforward problems, it's always worth giving some thought to the data structure you'll be dealing with in your code, because some data structures are going to be more useful for some problems than others. And if you choose the less useful one, then you'll just be making your life harder. So it's always worth thinking about here. So here we would think about data structures in terms of we've got our input and output, which we've already said is a string. And some people repeat that in the data one as well. I'm not going to. And then we can also think here about any intermediate data structures that we need. So by intermediate data structure, I mean something that we're not getting as the input and we're not returning as the output, but might be something that we use in order to get from the input to the output. So we might create a list of the alphabet. So it's not what we're getting in and it's not what we're putting out, but we might want to use the alphabet in solving the problem. So that could be an intermediate data structure. We might, excuse me, we might want to create a dictionary that is a tally of how often each letter occurs in a string. So the key would be the letter and the value would be the frequency that each of those letters. And again, we might use that because we're trying to just return the unique characters from a string or something like that. So we don't actually need to return that dictionary, and we're not getting the dictionary as an input, but it's like an intermediate data structure that we're going to use. So when we're working on problems earlier on in the curriculum, it can be difficult to think of an intermediate data structure that we could use because actually we're just getting the thing in and the thing out and we're just going to manipulate that thing, and so we don't need one. But sometimes an intermediate data structure does make the problem a bit easier, so it's worth thinking about. So can anyone think of a data structure that we might want to use? I'm just going to give you a minute for this because if you don't think of anything, we're just going to move on. A list. Jules, thank you. And what would we put in the list? Each character from the input string. So we could use a list of characters from the input string. Perfect. Each character from the original string, if that character doesn't match the previous character, added to the list. Each character from the original string. If that character doesn't match the previous character added to the list. I see. So, or I think you might be saying, if that character doesn't match the last character contained in the list. Yeah. So we could use a list to store the characters for the output string. So we might iterate through our input string and put each character into our output string only if the last character of the output string isn't doesn't match the next one that we're adding. So I was a bit distracted by reading Tom saying, am I right in thinking a set can't contain duplicates? That might be useful. Yes, I think a set would be useful. It's definitely something with Python when I see like unique. I do think sets because you can't add duplicates to a set. But here, because of that second test case, where we've got A appearing 3 times in the input and then it's appearing 3 times in the output, I think I probably wouldn't use a set here because there are duplicates. We just don't want them to be consecutive to each other, which is what other people are saying. So great, everyone's on the ball here. And sets are unordered. That's a good point. We need to preserve the order. That's another great implicit requirement, Jules. So one here, and I love this one. This is a great example of an implicit requirement. So we can see from those test cases, the order of the characters in the output matches the order of the characters in the input. And that isn't stated anywhere explicitly, but it's definitely a requirement. However, just because we've not noted it down doesn't mean it's going to trip us up. Because actually the way that we're probably thinking of solving this is that we're going to iterate through our input string anyway. And I think that's a good example of you don't need to sort of wring out every last requirement and rule you can get from the problem statement and the test cases. And you just need to sort of get enough that you're not being tripped up by things and be prepared to look back, because some of the rules that you don't write down are ones that aren't going to trip you up anyway, so you didn't need to write them down. And Tom, yeah, all good points. And actually, yes, all of these are good points about sets, but it's great to have that thought and just think about whether or not it is useful. And you know, this has really enabled us to talk about the difference between sets and lists, where sets aren't ordered and wouldn't be able to contain these duplicates. So it's a good discussion. No bad ideas here. Okay, so I think we've got enough for data structures. And now we need to write an algorithm. Now, it can be a bit of a leap to go from thinking about the requirements and data structures and just go straight into a step-by-step algorithm that's going to be really easy to code. So I find it helpful to come up with a high-level strategy to describe how I'm going to go from the input to the output. So it could be a sentence or two. Doesn't worry about initializing variables. It's in plain English, so anyone can understand the intention of what we're trying to do. And we might be able to come up with a few different strategies between us. So please put your ideas in the chat. And don't worry about how high level it is, just put something in there. So an example that is very generic, doesn't apply to this problem, but just to give you a kind of idea, but it is something that quite a few problems do fit, is where you're finding all possible combinations. Then you might filter for the combinations that meet a particular rule or condition, that might meet a particular condition. And then I want to find the optimum one for that. It might be the longest or the shortest or the biggest or the smallest or something. So that's quite high level. So just find all the combinations, filter the ones that need condition and find the optimal one. And that's the sort of level that I'm thinking at for a high level strategy. Again, this is a personal thing. It's something I find helpful. And so I encourage you to try it. But as you're working through and making the PEDAC process your own, you might find that this isn't helpful to you, or you might find that actually being that high level isn't that helpful, to go down a bit, just goes a bit too high level. I need to come down a little bit. But I just think it can be a bit of a leap to go from what we've got to just writing out. So I'm going to initialize a variable, and then we're going to iterate through this, and I'm going to test that. I find that quite hard. Okay, so has anyone got a high level strategy? I did see someone say, and it's disappeared now, iterate through the input string. Okay, I think this is quite hard. So what I'm going to do, I'm going to write my high level strategy. So, oh, hey, thank you, Jules. So create an empty list, iterate over the input string, and if each character doesn't match the final item in the list, add it to the list, convert the list to string when done, and return it. I absolutely love that. I would say it's actually got more detail in it than I need. It's almost good enough to just code from that. So I'm just going to take your middle sentence, because that's the key to this. So you're going to iterate over the input string, and if each character doesn't match the final, it doesn't match the previous character, then keep it. Okay, so that's a high level strategy. So I'm not talking about initializing any variables and returning anything. I just want to get to the crux of how I'm going to solve this problem. So I'm going to iterate over the input string, and I'm just going to see if each character matches the previous character. And if it doesn't, I'm going to keep it. And so now I can do a step-by-step algorithm where I'm going to use Jules's one. So I'm going to create an empty list. And I'm going to call this something. I'm going to call it output, just so I can refer to it later. Then Jules has told me iterate over the input string. Iterate over the input string. And I'm going to call that current character. And then I'm going to indent, because inside that iteration, I'm going to check whether this current character matches the final item in the list. So check if current char is the same as the last item in output. If they are different, append current char to output. And then the final thing is to convert the list to a string and return it. So once I've finished that iteration, I'll leave an extra gap there. Then when I'm done, I'm going to convert the output to a string and return it. Okay, so I'm going to create an empty list and call it output. I'm then going to iterate over the input string, and each character I'm going to call it current character. Then I'm going to check if the current character is the same as the last item in output. If they're different, I'm going to append the current character to the output, and then I'm going to convert the output to a string and return it. Now, the only thing I'm just going, oh, is this going to work, is that last test case where I'm getting an empty string in and I'm returning an empty string out. But I know I can write a guard clause for that if I need to. If the length of the input string is 0, then return an empty string. So I'm just going to chance my arm and write some code for the other test cases. If it doesn't work for that last one, then I'll just write a guard clause in. But I think it might work anyway. So why write a guard clause if I don't need one? So thank you, Jules. That's a great step-by-step algorithm. It's not the only one. There are different ways to solve this. So if you thought of a different way of doing it, it's absolutely fine. Actually came up with that really quickly. So now we are going to code with intent. So what I'm going to do is copy this, paste it over here, and make it a bit bigger. That's not that much bigger. No, let's make these all into headings. We'll go backwards with this one. And maybe just put space between each. So now you can see the algorithm that we are going to write in our code on the right-hand side. So I'm going to, first of all, create a skeleton for my function. So I'm going to call it crunch, and I'm going to have str as my input. And so, can anyone tell me what the first line of my code should be? I need to create an empty list called output. So what would the first line of my code be? Output. Yeah, excellent. Thank you, Shelby. So output equals an empty list. Great. Now I need to iterate over the input string. So how do I iterate over a string? And you are going to need to help me here. I've been working in Ruby and JavaScript today using a for loop. Okay, so what is the syntax for that? For character in string. Excellent. And now I want to check if the current character is the same as the last item in the output. So how do I do that? Oh, thank you. String is a keyword. Data might want to pick a different name. Okay, yes, I do. Thank you. That's why it's turned green. Right, I'll use string instead. Thank you, Jules. Okay, so how do I check whether the current character is the same as the last item in the output? Excellent, thank you. So if character is not equal to output -1. So I'm using the bracket notation to access a particular element in a list, and Python enables us to use negative indexing. So to get the last one, I just do -1. So if they are not the same, make that. Why does that? It's not. There we go. If they're not the same, you don't get an. Let's see. I might get an index error, Jonas. You're right. Let's see. If I do, we're going to need to fix it. So if they're not the same, then I'm going to append the current character to the output. So I'm going to do output dot append, and then I'm going to append the character. Okay. I could do a guard clause would fix it. Yeah. So let's just see. Then Oops. Then I'm just going to return the output. I won't worry about converting it to a string at this point. I'm just going to return the output. So if I just save, let's run this. I'm just going to do it for the first test case. So I'm commenting out the others. And what I want to do now is run that code. So I'm going to do Python daily double py and see what happens. So who said that? Yeah, Jonas was right. I've got an index out of range here because the output is an empty list. And so when I try to access -1, it doesn't exist. So what's another way I could do this? There are a couple of different things I could do. Has anyone got any ideas? If list empty, add the character. Perfect. So if length of output is 0, then I'm going to append the character. And then I'll change this into an else. Is it else if? Elif? Elif. So if the output has a length of 0, then just append the character. Otherwise, check whether or not the character is the same as the last element in the list. And if they're not the same, then append the character and then return the output. So let's see if this fits my problem. Yes, it ran. So instead of outputting, let's print it so I can see what's coming back. So let's have a look. I've got DAILY, still got the space, DOUBLE. So that is exactly what I want. Brilliant. I don't need to check whether the length is 1. It's if I've got nothing in there, then I'm going to put the first one in there. So that's why it works. And so then the last thing I need to do is to convert it to a string. Can anyone help me do that? Is it just string? No. Is it str? Does that work? No. How do I, come on people, how do I convert a list to a string? Join, thank you. Return, join, output. Here we go, right. True, yes, well done. Thank you, Jules. So now if I go back and uncomment these, let's see if it's worked for all of them, because it is that last one. I'm just going, oh, is it going to work for that one? Yes, it has. So I didn't need to worry about it, which is what I suspected. And that is because if I come here, there is nothing here. Like there's no for loop to do because there isn't anything in the string. So all of this, it will not do anything. And then I'll just join the output, which is empty, into an empty string. And that's what gets returned. So great. Well done, everyone. I hope that that has given you an overview of how to use PEDAC. And like I say, try not to be put off that it feels like it's going to take you longer to solve problems initially, because the more you practice using it, the quicker you'll get. And then when problems get more complicated, it will make things easier. So let's just increase the size of this. So debugging. Does anyone have any questions about the PEDAC process before I move on to debugging? No. Right, so bugs are when our code doesn't work as we want it to, and debugging is the process of getting rid of them. It's the bread and butter of what programmers do. In an ideal world, all of our code would work straight away and never break. But the reality is that we do make mistakes and environments change. And so getting bugs doesn't make you a bad programmer. It just makes you a programmer. So one of the most important things, can I put the written PEDAC back up on screen? There we go. One of the most important aspects is our temperament. So it's essential to be logical and patient and not angry and just trying to get on with it. And it can be difficult because normally the bugs arrive when something's broken. It's a bit frustrating. But try and approach problems with a detective mindset. And I think actually maybe this is easier to do when we're studying, because when you've got a bug, you're probably about to learn something. And a little higher as well. Do you mean the high level one too, like that? Yeah, so when you've got a bug and you can't spot it immediately, you're about to learn something. It's often, I still have this now. I think, oh, there's something fundamental that I don't understand. It isn't. It's just that I've got the syntax wrong. I've put a full stop where I shouldn't. I've missed a bracket, particularly in JavaScript. So don't panic, just work through things step by step and you will find it. Computers don't have a mind of their own, and they are only doing what you're telling them to do it. So try and be logical and patient. You will often get an error back, and this error has at some point been written by a human and they're trying to be helpful, so use it. They can be a little bit intimidating at first. So we've got a stack trace here at the bottom. So focus on the bits that you can understand. Trace stack. So this is telling me that this is a stack trace. Useful. File is telling me where the file is. So it's useful. It's the one that I've just run. And it's telling me exactly where the problem is. It's on line 14. And then it's giving me the code on that line. Print center of I love Python, py true. Okay, and then it's telling me which line then called that line. So it's sort of like a stack trace. It's tracing through the program. And then it gives me the error type. So the object of type has no length. Bit cryptic there, but I'm trying to call the len meth function on something that I can't. So that's what I need to think about. And I need to have a look at line 7 and line 14. So the more practice you have with reading stack traces, and you probably will have a lot of practice with it, the better you'll get. If looking at the code, you still can't think what it is, you can Google the, you could Google this bit, type error, object of type, and see what comes up. You can look specifically at Stack Overflow. That might be one of the results that come back when you Google, and there's lots of useful things in there. And then also check the Python documentation for maybe the data structure that you're using. You can also use a trusted AI assistant for help. Just be careful when you do that. I mean, it's a really useful tool, ChatGPT. I use it. The only thing I think is that we're all being told at the moment is that AI is supremely confident in the answer that it gives, regardless of how sure it is. So they can make mistakes. And when you point it out, you know, they're very polite and great at apologizing. So, you know, don't just believe what you're being told by AI, check it out. If the stack trace isn't speaking to you, it's just not helping, read the code, read it out loud, read everything, because that may be where you spot that you're missing a bracket. Rubber duck the problem, explain the problem out loud. like you're talking to with eponymous rubber duck, cats work fine too. Forcing yourself to articulate the problem can sometimes unlock the issue. Sounds weird, but it works. Just as you're describing something to somebody, you go, oh, yeah, that's what it is. One of my favorite things is to print stuff. So when we were working through this code here, I'm just going to comment now here. What I do like to do is to use print commands to check that the code is working as I think. At each point at which I've written some code that I could test, I might do this. So again, I'm just going to comment out all except the first test case. So here I've just created my output. I'm pretty confident that line's right. And I've got a 4-character in string. I'm just going to print the character just to check that I am hitting every character. And I have got the syntax right for a for loop. So if I save this and then run the code, it gives me all of the letters I've got here. So 2 Ds, 2 As, 2 Is, 2 Ls. So then I can go back here and I could be confident that I've got the syntax right for this bit, and then I can continue writing. And so you can do the same when your program isn't working. I start from the top and just work it and just figure out if each line going down is doing what I think it should be doing. And then at some point I'll get to where it's not doing what I think it should be doing. So outputting stuff, use print, for me is really, really helpful. And I start from the top. It can be tempting to start at the bottom because you think, oh, the top's all right, something happening at the bottom. But the problem with that is that when it's not working, you just keep going up, and it can be difficult for me to keep track of where I was. And also by working from the top down, you're making sure that each line of code is getting the correct thing from the line before, rather than, if you think of it as like a conveyor belt of maybe some sort of factory making things. If you start at the end, you just see this doll come out with a leg on the head or something. And then you say, well, that's something gone wrong there, and I go back, and then, or maybe the arm is also not right. You just have to keep going back until you find the problem, and then you've got to go forward again to check what impact that's had on the rest of the code. Whereas if you just go to the front of the conveyor belt and just say, well, hang on a minute, is it getting the torso first? Because everything else has got to be stuck onto the torso of this doll. Then you can know, oh, that's okay. And then the next thing it gets is the head, and it does put the head on there, so that's fine. And then it gets the leg, but it's putting the leg on top of the head. So that's what I need to change. I need to make sure the leg is going on the bottom of the torso. So you can imagine if you're working from the top, it's kind of easy to see what's going wrong and easy to fix stuff before it's affecting other bits of code, because a bit of code further down might not be working, but it might be because of something earlier on. Okay, and then the last thing is you walk away. So if you're finding that you're getting really frustrated and just can't see the wood for the trees, obviously you can't do this in an interview, but most of the problems you'll be solving are not in an interview. Walk away, or don't walk away, just work on something else. Go make yourself a cup of tea, have a scone. I often find these things, you know, I just can't think how to solve this problem. And debugging is the same. What is going wrong with this code? Just find walking away, thinking about other things. I'm still thinking about it in the back of my mind, and I might go, oh, aha, that's the problem. So walking away just lets you get your diffuse thinking going on. So that's the summary of debugging. I've hit the hour, so I'm not going to do any more on debugging there. This is what we've covered. So we looked, oh no, that's not right. So we looked at the PEDAC process, and we solved a problem together. And then I've talked through some strategies for debugging. So just to go back through that, try to be logical and patient. Look at the stack trace. It's been written by another human being to help you. Read the code line by line. Really read the code. Rub it up. Try to explain it to somebody else. Print from the top, or walk away and come back and try those things. Does anyone have any questions for me before we round up? Anyone that's really got to go, I'm just going to put the feedback form in there. Please fill it in. It would be really helpful for you to let me know whether this worked for you. And if you've got any ideas for how to improve it for next time, because I've not done this before. And yeah, if you've got any questions, put them in the Q&A. I can't see the questions coming in, so I must have just been completely crystal clear. So now if I bring up the conclusion. Okay, so this was the last in the set of 6. So I hope you've enjoyed all of this. You know, your call to action now is to be putting all of these things into practice, and particularly the PEDAC process, because the more you use it, the more useful it is. Honestly, I'm a complete convert. Give it a go. I know it might feel like it takes longer to begin with, as I've said, but it really helps. So give it a go. And remember, you know, it's a really good community at Launch School. So make sure if you've got any questions in the prep course that you message us in the Slack channel for prep course. And then once you're subscribed to Launch School, then there is a Slack channel for each course as well. And then there are the discussion tabs where you can ask questions and TAs will answer them. And then we've got other communities like Gratuitous Pet Photos. That's nice for connecting with people. Been having a lot of fun on the random banter today. People are trolling me about what scones are, and someone thinks all round things are biscuits and tea. So that's a lot of fun. What's another one? It's fun. Oh, and then the women's group as well. So we meet every 3 weeks. And there's a Slack group for that. So that's another scones discussion. It's hilarious. I'm glad that you're enjoying it. So I'm having fun. Yeah, so please fill in the feedback form, and yeah, I'll see you all around. If you've got any questions or anything, you can always reach out to me on Slack. We're all really friendly here, and enjoy the rest of your day. It's Friday. It's 11 o'clock at night for me, so it really is the weekend. Might have a couple of things to do before I need to go to bed, but not much. So thank you all for participating and not just leaving me hanging. Yeah, and enjoy the rest of your day. Goodbye. Okay, wait a minute. Didn't want to interrupt too much before, but could you put back up each letter of the written PEDAC for a few seconds? Yes, I can. The PEDAC process. There you go. Okay, so I'll leave that hanging there for a little bit. So you can screenshot it, I suppose. You mean the one in CodaPad? Okay. Yes. Oh, it's going to be quite hard for me to. How are you going to read all of that? Do you want to slowly screenshot each bit? Tell me when to move down? Ready for the next one. You're welcome. So I take it you've got the rest. Right, wonderful. Thank you, Jules. Bye, everyone.